Hi everyone, Sami here. Welcome to Let's Make BGP Talk Part 2. In the first part, we have seen how a BGP pairing session goes through the finite state machine. In this one, we will look closely at the different BGP messages. We will also discuss their roles and functions. Every BGP message starts with the same header. This is a very simple header. It has the total length and the type of the message. The first field, the marker, was used in earlier versions of BGP with authentication. In the last version, it is no longer in use. It must be set to all ones. Let's get back to our packet capture and look closely to the messages. So here we have the open message. And here we can see the header. Starts with the marker, the length of the total message, and the message type. Here again, and this is the keep alive. Notice that the keep alive has only the header. And here is an update. They all have the same header. BGP has 5 types of messages. There is the open message, the update, the keep alive, the notification, and the route refresh message. We will be talking about each one in detail. We have already seen the open message. This is sent immediately after the TCP session is established. This message contains information about the local router. For two routers to establish a BGP pairing, they need to validate each other's open message. So the information right here represents the local router. We have the BGP version. It has been version 4 for at least the 2 last decades. Then we have the local autonomous system number. The whole timer is a timer we communicate to the remote peer. If it doesn't hear from us for that period of time, it can declare us dead. Then we have the BGP identifier. This is the local router ID. Then we have the optional parameters and its length. This field was used in the past for authentication, but that had been deprecated a long time ago. With the current version of BGP, authentication is handled by TCP. The other important function of this field is to communicate the capabilities of the router. There are many types of capabilities. Sometimes a router will expect its remote peer to support a certain capability. If it doesn't, the session will be closed immediately. Some routers could support a capability and would be fine if the remote peer doesn't. This is an advanced topic. We will talk about it much later in our course. For now, it is good to be aware that a mismatch on the capabilities between two routers could possibly prevent your BGP pairing session from coming up. Let's have a look at our open message in the packet capture. So we have the BGP header, and the version, it is the BGP version 4. I had set the autonomous number to 1. Hold time is at its default value, which is 180. BGP identifier, this is the router ID. I didn't configure it explicitly, so it has automatically chosen the highest loopback. And then we have our optional parameters. They are all capabilities. Let's look at the first one. This is an address family. Let's see which one is it. This is unicast IPv4. We will be talking about the capabilities later on this course. The BGP keep alive message. We have already seen in the BGP peer finite state machine that the first keep alive is used to validate the parameters in the open message of the neighbor. The subsequent keep alive messages are used to determine if the two peers are still reachable. BGP uses TCP for many of its functions, like authentication or packets acknowledgement. But the BGP RFC explicitly says to not use the TCP-based keep alive mechanism and use a dedicated one. We have seen in the open message that the routers communicate a hold time. The lowest value is used, and the periodic interval of keep alive messages is 1/3 of that hold time agreed on. The minimum value possible is 1 second, and for the hold time it is 3 seconds. The hold time could be set to 0, which disables BGP keep alive mechanism. If we get back to our packet capture, we can see that our Cisco router is proposing a 180 seconds hold time, while the Juniper router is proposing a 90 seconds timer. The lowest one will be selected as the hold time to use, and the keep alives will use 1/3 of this value, which means a periodic interval of 30 seconds will be used for the keep alives. If we go back to our Cisco router to check the hold timer, we can see that it is 90 seconds and the keep alive is 30 seconds. If we get back to our packet capture, we can see a bunch of keep alive messages. If we look inside one, we will find only the BGP header. There is also an important thing. If we look at the keep alive sent by our CSR 1000V, we can see here the time at which the packets were sent. If we look closely, we can see that the interval isn't really 30 seconds. This is because there is a negative jitter of up to 20 seconds of interval used. In other words, we subtract from 0 to 6 seconds from the 30 seconds. This is part of the BGP RFC specification. The reason for the jitter is to prevent congestions caused by keep alive bursts when there are a lot of BGP sessions. The random jitter allows to desynchronize the keep alives and not send them all at once. The notification message is sent when an error condition is detected. This message causes the BGP connection to close immediately. In addition to the BGP header, the notification message has 3 fields. A code which indicates the type of notification, the subcode further indicates the nature of the error, the data provides additional information for diagnosis. So let's get back to our routers. Now we are in router 1 and let's try to cause a notification message. We know that router 2 is using a hold time of 90 seconds. So what we will do is configure router 1 to use a keep alive of 60, a hold time of 180, and a minimum acceptable hold time of 180 as well. To make the change take effect, let's bounce the BGP session. Okay, here it is. We can see here the notification message. What does it say? Unacceptable hold time. Let's get back to the packet capture and look for the notification messages. Here we can see that the notification is sent immediately after router 2 sends its open message. Router 1 responds with a notification. If we look inside, we can see the header. It is a notification. The code is 2 and the subcode is 6. but there is no data actually. The list of notification error codes and subcodes can be found in the RFC. Here we can see that the error code of 2 means that it is an open message error, and in the open message error subcodes we can see that 6 means that it is an unacceptable hold time. This is just to confirm what we have seen in Wireshark, but you don't have to remember any of this. The update message is the most important one. In this lesson I will be brief about it, but we will talk more about the update message in upcoming lessons. For now, what you need to know about the update message is that it is used to transfer routing information between two BGP peers. The update message can signal routes that are no longer reachable through the withdrawn routes. It can also simultaneously in the same message signal a path with its characteristics through the path attributes. A single update can advertise only a single path, but a single path can lead to many prefixes. In BGP they are called network layer reachability information. We will come back to this later. What you have to remember for now is that the BGP update message is used to advertise and withdraw prefixes. Then there is the BGP route refresh message. This is also something we will be discussing later when we get to routing policies. For now, just know that this message is used to request from a peer to re-advertise its routing information for a particular address family. Just for the sake of the demonstration, I will ask from router 1, router 2 to re-advertise its prefixes for the address family IPv4 unicast. Okay, now let's check the packet capture and see what happens. Okay, here it is. Router 1 is asking router 2 for a route refresh. We can see the address family, it is IPv4, and the sub-address family, it is unicast. It is worth noting that router 2 isn't answering with an update message because it isn't advertising any prefixes yet. I do have prefixes configured on router 1, so let's go to router 2 and ask for a route refresh. Okay, let's see what happens in the packet capture. Okay, so here is the route refresh from router 2, and we can see that router 1 is immediately answering with an update. And the update carries the prefixes. Here we can see that there are two update messages, one for each path, and each path has its own prefixes. That was a long one, so what do you need to remember from this one? The BGP messages are open, update, keep alive, notification, and route refresh. We have first the open message. It advertises characteristics of the local router. The keep alive, it is first used to validate the open message received from the neighbor, and then it is used as a keep alive mechanism. You have the update message. It is used to advertise and withdraw prefixes. The notification message is to report an error, and it immediately closes the BGP session. And then the route refresh asks for prefixes to be re-advertised.